How's it going, YouTube? I'm back with, we'll call this T38 build series. Episode 1, Volume 1, Chapter 1, I don't know, however you want to look at it. So, anyway, here you have the T38 main fuselage. It's a 1.25 scale, which is 118 inches long, 65-inch wingspan or so. And we're hoping for about 35 to 38 pounds ready to fly for both the EDF and the turbine version. Primarily it's going to be situated for twin EDFs around 110 millimeter. And a single turbine around 40 to 50 pounds of thrust or so. I have to apologize for the camera bouncing around. I'm trying to get it situated so y'all see the same thing I see when I throw my hands up. So anyways, 118 inches, 65-inch long. The entire plug is 3D printed. I think we used about 30 kilograms of material, 40 kilograms, something like that. So, yeah. Whole thing's 3D printed, then the individual segments are just CA glued together, which works out really well. 3/4 inch long pipes that run the full length of the fuselage. I believe there's 5 of them for the fuselage, 3 for the nose, and then just 1 or 2 or whatever for each wing panel. And after that, once I got everything glued together, I sprayed the entire airplane with Directx gray primer. It's their primer surfacer, which is this darker gray color. This stuff works really well. It's a polyester-based product, which I'm not a big fan of polyester-based product, but this stuff has kind of convinced me otherwise when it comes to finishing tooling and whatnot. The stuff is just amazing. The gray stuff will spray up to a 1/16 of an inch thickness without running. The tan color you see is also a Directx product. That's a Directx base primer, and that they say will build up to an 1/8 of an inch thickness without running for a single application. And based on what I have seen with this project, I will say that that is entirely accurate and not just a marketing gimmick. It builds up extremely well, and it doesn't run, especially the gray stuff. The tan stuff, I haven't sprayed it. I just brush it on and just let it run if it wants to. I was just going for maximum thickness. It didn't really care about surface quality. Excuse me. Wife made cookies earlier, and I don't know, maybe that one's not agreeing with me. So yeah, I mean, that's the fuselage in a nutshell. See, we got wing roots molded part of the fuselage. Pretty much locks everything in place. I got a little bit of the vertical stab stuff is molded in there as well. It's going to be one of the more complex fuselages I've ever had to mold, just because of all the shapes and the undercuts. And then you got stuff like the 90 degrees here on the wing and the vertical stab edges. You got the anhedral on the horizontal stabs. I mean, there's a lot going on with this fuselage, so it should be pretty interesting when it comes time to mold it. I got the nose section over here on my downdraft table that I built a few months back. The downdraft table works amazing. I just laser cut out a cradle for the nose section out of 2-inch insulation foam. Got the nose here. Next step with the nose, you can see it's got a lot of the gray Directx that hasn't been sprayed on at all. Next step with this thing is to get the canopy plugs and stuff fitting better. They fit fairly well, but due to, I guess, them being 3D printed and completely sealed, I believe the inside, the air just kind of fluctuates or changes, expands as temperatures change. And what happens is the bottom of this has actually developed a very slight bow, so there's a gap around the edges. So right now I'm debating, I'll probably put a hole or 2 here in the bottom of it for an air vent, and I'll likely heat this entire section up with a heat gun to where it's really nice and soft, because this is PLA. If you're 3D printer guys, PLA, you know, it gets soft really quickly at a low temperature. So I'll get it super hot, and then I'll just bring it over here to the table, slap it down. You can see the rock it's got now, maybe, I don't know, but there's a little bit of rock there. But heat it up, push it flat until it cools down, and then we'll see how it fits. Maybe I'll get lucky and I won't have to do any body work, and it'll just be a matter of flattening it out, maybe a little bit of body worker on the edges of it just to kind of sharpen it up, and then there we go. If that doesn't work, I'll do like I did with the main engine hatch, And you see I've got these lines here. And what I did with the main engine hatch is I drew these lines and I cut out everything in between them on the bottom of it, and then put body filler here to build it up to get it nice and flat with what would be this surface of the fuselage. But hopefully I won't have to do that. Hopefully just heating it up and pushing it flat with a vent hole or two will work out perfect, and it'll end up being perfect. And then it'll just be a matter of Directx primer on the bottom of this to get rid of the striations that you can hear right now. And if that works out, these plugs will actually be basically ready for the final coats of Directx. The fuselage right now is ready for the final coats of Directx, as are the wing panels and the horizontal stabs, vertical stab, all of that stuff. So yeah, let me grab the phone. We'll come back over here into the what I call the tool room. As you can see, it's kind of dark, especially in this corner. That's because F14 mold blocks all the light from it. But you can see I got just shelves of stuff, tires, foam, whatever. It's kind of it's a mess in here compared to the other room. But here you can see I've got inlet duct plugs with aluminum tubes to hold them, so when you go to do it, it'll be nice and easy. All my ductwork, I believe I'm going to use fiberglass and carbon fiber sleeving and heat shrink to make, which should make making these extremely quick and easy. Just a matter of sliding it over, wet it out, heat shrink it all down until it goes green, take the heat shrink off, and then just run a knife blade right down the edge, down the center of it, just like that, to cut it, and then peel it away, and then just re-seam it back together. So there's that. Here we have one of the main landing gear strut gear door molds. You can see it's been 3D printed as well, and this just had body filler smeared over it to get rid of the layers. You can see a little bit of the layers from it. Let's see if I can get it on camera just right. I don't know, you might not be able to see it, but there's a little bit of low spots where it just needs a little bit extra primer. I'm going to throw 2 or 3 more coats of the gray Directx on this, wet sand at 400, and then the laser cutter will come out here and we'll etch all of the gear door panel lines, screws, and all that stuff on that. So yeah, that's the main one. I got the other one done as well. Here's the nose gear door mold. This one may end up becoming a little bit more complex because of this, and I'll probably end up 3D printing some parts to go around it to build up a little bit of thickness, and then do the inside structure of the door as well. There's that. Up here, oh, I don't know if y'all can see that. I gotta get my trusty dandy, my phone over here so I can see. Here we got a rudder. Hopefully you guys can see. You see the white rivets here, and there's some red ones as well. All the rivets were vinyl cut, already put out. Some are missing, like right here there's one that's missing, there's one missing down here, there's a couple missing up here. I could probably go through and replace those missing ones, but even on full scale, some rivets you just don't see, so I'm not too concerned about that. Horizont Stabilizer, same thing. See, all the rivets already there. They're running around scale area as best as I could tell. There's not a whole lot of detail as far as what goes what on the horizontal stab, so I just kind of had to guess what I could figure out. But these are ready for the last coats of primer. Probably going to be Directx as well. And then I'll wet sand it down to where all these rivets are sticking out, and then go through the painstaking process of individually popping out each one of these little vinyl rivets. So that should be fun. Wing panels, let me read this camera here. I'm not going to drag those out, but the wing panels are basically the same. They're the same status as the gear door molds were. They're ready for another coat or 2 of Directx, and they'll be ready for etching of the surface detail. All of the surface detail on the wings I'm going to do with the laser cutter. And here we have the vertical stabilizer. Readjust this camera once again. You can see it's got a whole lot of detail to it. All the detail on this was done on my vinyl cutter, and it's pretty much all done at once. All the rivets, all the panel lines, everything. I didn't have to really do much to it. And then, of course, all the little silver stuff is actual screws that I've drilled, countersunk, and put that in there. And then the little black things you see here and there. These were 3D printed additions I did on my SLA printer, then brought on here, then just CA glued them on. This is also ready for the final coat or two of Directx, and then it'll get wet sanded, polished, and all that. And then I'm going to do some scale surface variations as far as the waviness and whatnot. So when I get ready to start doing that, I'll show you guys how I go about doing that as well. So yeah, that's pretty much the T38 project in a quick nutshell right now. Hopefully this video recorded. This is the 5th or 6th one I've done that I have recorded, and then come to find out at the very end, for whatever reason, this stupid little cheap eBay wannabe GoPro, or Amazon wannabe GoPro, stops recording a minute or two in. So here I am, 10.5 minutes. Hopefully this works out. So I'll wrap this up to see how frustrated I can get if it didn't record again. So, until the next video, you guys have a good one. I'm going to go back to do some